Hello everyone, I am from group 2. And this is our project demonstration for characterization of solar cell. We will be doing IV and PV characterization here. This is our experimental apparatus. Here we find that the little dots that we are seeing here, they are the MOSFETs and they are using as a switching device. As we are using a small PV panel 90mm to 90mm, and the rating of it is 5 volt and 200 milliampere. So we needed the small MOSFET for to be used as in the gate current section. Here we have used a bank of resistance to use them, to utilize them as a variable resistance. So from open circuit section we are leading towards the short circuit section. So and we will be using here we have about 12 samples, but we will be using a series of combinations by pulsing two gates or four gates at a time and getting different various resistance combination. And here we are using the voltage sensor here for analyzing the for detecting the voltage, and also we are using current sensor INA 219 for getting the current data. Here we are using INA 219 because the PV cell is small and we will be generating little amount of current. For large PV cell we will be use ICS current sensor that can take about 15 ampere to 20 ampere current data. So we are using INA 219 here because we have a small current generation here. And also we have Arduino Uno for that is connected in COM6 in our local laptop, and that will be providing us the data that will be used for further data processing and analyzing the characteristics of our solar cell. Thank you. From our experimental apparatus, we are transferring the data from Arduino to our local PC, and we are using MATLAB for visualization of the IV and PV characteristics. From the first, we find that it is connected to serial port COM6 and with a baud rate of 9600, and then we make a simple array to store the datasets, and then we update the datasets via the data that we find from the Arduino. Yes, there is a sampling time difference between MATLAB and Arduino, so obviously we need to delay the MATLAB sampling time so that no data gets lost in due to synchronization error. And again we sort the data and plot it via plotter, and we save the dataset also. If we run the section, then we find that it clearly depicts the it is currently processing. It depicts the typical IV characteristics. First of all, we find the IV characteristics and later we find the PV characteristics. And via further analysis, we find that we get a maximum point, our MPP, to be at 4.4795 volt and 47429 with a power of 607. And via further analysis, we find all the characteristics that we study in our theoretical studies. And from the shape of the graph and from the first observation, we find that it matches with the theoretical study. So we have successfully demonstrated our PV panel working for our PV panel working to simulate the IV characteristics and PV characteristics. So thank you. Processing section for smaller PV panel. Here we have taken the sample dataset that we have taken the sample dataset in full illumination. We have saved this data solar data to .mat, and then as we are going to interpolate, there shouldn't be any duplicacy. So obviously we are going to increment the data. We are going to change the data a little bit, but the deviation is not negligible to interpolate the function. Now we are going to fit the dataset and we will find IV curve and PV curve. Then we will differentiate it to find the series resistance and shunt resistance. And finally we are going to analyze it to find the maximum power, shunt current and other parameters. So running this section, we find that it clearly matches with the theoretical study, the IV curve and the PV curve. And then going to the post processing section, we find the series resistance, shunt resistance.
here the ISC and VOC that matches with the data nameplate dataset that we found from the purchaser of smaller PV panel. So we were successfully able to calculate the characterization of our smaller PV panel. Thank you.